Okay, welcome back, everybody. My name is Delzy. In today's class, we're going to be looking at chemistry practical, the experiment one. The title of the experiment is Measurement in Chemistry, Volume Changes Accompanying the Mixture of Liquids. Okay, the objective of this experiment is to investigate the change in volume upon mixing two common liquids and to ascertain if volume is conserved. Okay, the procedures is listed in the screen, but before we start talking about the procedures, it's very important we actually, you know, run through the apparatus that is needed here. Now we need the following. We need transfer pipettes, volumetric flask, thermometer. This they won't really give to us. The graph of density versus water, they won't give to us. The analytical balance, yeah, they will give to us. Volumetric flask, pipettes, LMR flask, distilled water, any of the following liquids, the be ethanol, methanol, propanol, or acetone, right? Acetonitrile, diethyl sulfoxide, diazine, acetone. Okay, any one of these liquid that is actually available in the lab, possibly they'll give to you guys. Okay, now the first procedure, like I said, the graph of density versus water, obtain the density of the water at the laboratory temperature. Okay, this particular first procedure, we don't have to do anything. Yeah, they'll give you guys a value in the lab. So laboratory. Okay, just like we know, practicals require that we have our apparatus and our reagents. So I think I have some of them here to present to us. So I'll start with the reagents. In this experiment, since we are checking volume conservation when mixing of two liquids, we have two liquids here. The two liquids we're going to be making use of this is alcohol, right? My right hand side is alcohol, and we have my left hand side is water. If you actually notice that both of them, the texture is almost the same, the color is the same, they are colorless to start with, but I had to use this label here to actually demarcate the ethanol from the water to avoid making mistakes. All right, so this is my ethanol, sample B, and this is my water, sample A. So anytime I say sample A, I'm referring to water. Anytime I say sample B, I'm referring to alcohol or ethanol precisely. Please let me state this. In the lab, this second liquid, right, can vary. They can actually give you guys acetone. It's not compulsory that you're going to make use of ethanol. If you go through your manual, you realize that they said water, distilled water, and any other liquid such as ethanol, acetone, isopropanol. All right, so when you get to the lab and then you get to see acetone, you're not supposed to be confused, right? The purpose of this experiment is to make you understand how to use this, how to carry out this experiment. Okay, now moving further, we have our volumetric flask. If you notice this volumetric flask, you can see the size and the shape of the flask. Vertically, we have this guy projecting up, and then we have the base, which is a bit large. Right, this is a 10 ml volumetric flask. In your manual, they requested that we make use of 10 ml, right? But most of the times in the lab over the past years, sometimes you could just ask them to use 25 ml. So whether it is 25 ml or 10 ml, if you actually follow us through this video, you should understand how to make use of this 10 ml. So when you get to the lab, if you get hold of 25 ml, you should be able to know how to do it as well. Please take note that this cover is always used whenever you're weighing this, except otherwise stated in the lab. But for the past years, they've always been making use of this cover. All right, so you have to cover it and weigh it. All right, so if you actually feel something to this, at the end of this, you have to cover it and we weigh it again. All right, this is my weighing balance. All right, this weighing balance, basically, I'm putting it on now, is actually what we're going to be making use of to carry out the measurement of the weight, all right, of these substances, these materials here. So this weighing balance or analytical balance. Now this is a bigger size LMR flask. Now the main purpose of this flask is basically to help us carry out mixture of liquids and to also store liquids, right? Okay, so this LMR flask, if you notice the shape of the flask is different from that of the volumetric flask. You can notice LMR flask, volumetric flask. Also, we have another LMR flask. This is a smaller size LMR flask, 25 ml precisely. Okay, so if you look at this flask, we're going to be making use of it here, right? So it's best you get to know or acquaint yourself with how these flasks are, and then in case you get to the lab. And we have pipettes. Every one of us here know what pipette is. In secondary school, we are very conversant with the 25 ml pipette that has bulb at the center, right? Now in the secondary school, you always use your mouth to suck pipette, but in the university, in order to avoid liquid getting access into your throat, there's what we call pipette sucker. These are my personal property. I bought it from the store. So, but in the lab, I think they can give you something similar to this, or something that will help you pull out the liquid to the pipette without having to suck it through your mouth. Okay, so that's just the rundown of the apparatus and the reagents we're going to make use of. So I'll be guiding us on how to carry out the experiment, the step-by-step procedures of how to go about it, and most importantly, the calculations. Now, the first procedure, like I said, the graph of density versus water, obtain the density of the water at the laboratory temperature. Okay, this particular first procedure, we don't have to do anything. Yeah, they'll give you guys a value in the lab. So the value they gave them last year, okay, is 0.9973 grams per mil. Now I've actually carried out the practical, so I'm going to be submerging the videos with this screen recorder, all right, so that it makes more sense for us. So the first procedure, which is actually from the graph of density of water, obtain the density of water at the laboratory temperature. Okay, so in this case now, the temperature of water, they'll measure it, and then from there they'll get the density of the liquid and they'll give to you guys. So the density of the liquid, the one they got last year, density of water, the one they got last year was 0.9973, and I don't think there's any difference between last year and this year. All right, so water doesn't really change density as the year goes by. Okay, now for the procedure 2. All right, the procedure 2 is calibration of volumetric flask. All right, calibration of volumetric flask. All right, so this is my volumetric flask. From the instruction, they said weigh the flask dry and when filled to the mark with distilled water. Now, if you take a look at this flask, there is a line here, right? This line is actually the mark on the flask, and this is 10 ml volumetric flask. This volumetric flask is 10 ml. You can see it here is 10 ml. Okay, so we want to actually calibrate this. The main purpose of calibrating this is to make sure that the volume we're told that this guy is actually the volume. The manufacturers of this flask told us is 10 ml. Right, so we need to carry out calibration to be very, very sure that this guy is indeed the 10 ml. All right, so the instruction we are going to follow here, they said we are going to weigh this flask when it is empty. You're going to weigh it with this on top of it. So I'll put this on my weighing balance. All right, the mass of the volumetric flask when it is empty gave me 16.5 grams. 16.5 grams. Where exactly are we going to record that? Of course, in your data table to be displayed on the screen. Now, I'll bring it out. Now they said we fill this guy with water to the point where it is marked. Fill this guy with water to this point where it is marked. You see the point where it is marked here. I want you guys to see the point where it is marked, and then weigh it again. Now I'll use my pipette to actually take the volume of water. So I'll actually plug in. So this is this. I take my water. I come here. You notice there's nothing inside this flask. I release this. Right, it has not got into the mark, so I come back again and take another water. Come back. I need to be very careful so it doesn't exceed the mark. All right, so if you look at this now, I filled this volumetric flask with water because from procedure 2 they said weigh it when it is empty and weigh it when it is filled with water. So I've actually filled it to the mark. This is where the line is. The meniscus cuts here. So I'll come back here. I'll cover this. I've covered it. And I'll weigh it. And the mass of the mass of this volumetric flask when filled with water, right, up to that mark, gave me 26.5 mil. 26.5 mil. Okay, it gave me 26.5 mil. So in this case now, I have to come down to my experimental data table and I'll record it. When it was empty, we got 16.5 grams. When it was filled with water, we have 26.5 grams. All right, so I want to first of all carry out all the tables. Then we can now start our calculations. So we want to carry out, now we proceed to procedure 3. We want to carry out the density of the second liquid. So they say fill the calibrated flask with a mark with any of the other liquid and weigh. From the weights of the liquid density, obtain the density of the liquid. All right, so this is what we're going to do. All right, now we had earlier weighed the mass of the other liquid plus ethanol. I'm going to send the video. Okay, so we have earlier carried out this mass of flask plus other liquid, gave us 24.9 grams. Do you understand? So we got this already. We got 24.9 grams. So now I'd like us to watch the video so that you understand what I'm talking about here. Okay, so we'll now want to move down to procedure 3. All right, now I'll empty this into these flasks. Right, I'll empty this. Now procedure 3 said determination of density of the second liquid. The second liquid in this case is the ethanol. We do not really know the density of this guy, but we know the density of water from experiment 1. They say we should use the graph of density of water versus temperature, which I told us that they will always give that value in the lab, so you don't really have to stress yourself. And the one of last year is 0.9973, so you should watch out for this year. It's most likely going to be the same thing because water is actually water, whether it is last year or this year. Okay, so for the procedure 3, we are asked to determine the density of the second liquid. The second liquid in this case is ethanol. Right, this is ethanol. Okay, so I have to first of all use this ethanol, take some quantity of this ethanol to rinse this flask, right? Okay, so I'll come here, I take little quantity of ethanol, I'll put inside this flask, just to rinse it. Okay, so we are set for the procedure 3. The procedure 3 said fill the calibrated flask. Remember, we have earlier calibrated this guy from our calculation, right? Fill the calibrated flask with any other liquid, not water. In this case now, any other liquid we are using here is ethanol. Remember I said this particular any other liquid in the lab, they might decide to give you guys acetone, right? Or they might decide to give you guys alcohol, which is ethanol. So we are using ethanol here. So I'll open this. I'll take my, right, since I already done the first one, I'll come here. I'll empty it into the flask. I'll come here, pick another one. All right, so that is it. Exactly at the mark point, which is this place. If I bend it. Okay, so I'll cover this. I'll have to cover it. I've covered it. I'll place it on my weighing balance. Now, the mass of the volumetric flask with any other liquid, which in this case is ethanol, gave us 24.9 grams. 24.9 grams. All right? 24. In this case, now the other liquid in this case is ethanol. All right? So 24.9. Now we proceed. Remember, I don't want to touch anything here until I'm done with the entire procedure before we start our calculation. All right, so let's look at the previous page, calibration of the pipette. All right, okay, so I made a video for this, but I'm going to play it now so that it will be very easy for us to understand. Okay, so
okay,
now
look at procedure 4.
Procedure 4 is calibration of transfer pipettes. Now these are transfer pipettes. While we're calibrating all these measuring apparatus, we just want to verify that the volume we were told by the manufacturer is truly the volume this guy would be delivering. We were told that this flask is 10 mil, so we need to be very sure it's actually 10 mil. We carried out our calculation. We had to weigh the flask when it is empty. We filled it with water, and then from density equals to mass over volume will now be mass over density. So we got the volume of the flask. So this pipette here, we're told is 5 mil. Okay, if you look at it very well, let me show you. If you look at it very well, there's 5 mil here. We are told that this is 5 mil. Okay, so we want to verify that if truly this guy is 5 mil. But unlike the volumetric flask, we cannot weigh the pipettes, when it is empty. So basically what we are going to do here, right, we're going to follow the instruction in the manual, right, but I'm going to tell us the best way to go about it. All right, now look at this. First and foremost, from the instruction they said, use the transfer pipette to deliver 5 successive aliquots of each of the 2 liquids into the small LMAR flask. Now this is a small LMAR flask, right? So we have 2 liquids, water and ethanol. So we're going to do the same. We're going to do the same thing for ethanol. We're going to do the same thing for water, but I might not really do it for both of them. Do you understand? If you understand how I would do it for water, it's still the same thing that I'm going to do for ethanol. Very simple. Do you understand what I mean? Now listen, class. It said, use the transfer pipette. This is a transfer pipette. Deliver 5 successive aliquots of each of the 2 liquids into a small LMAR flask, which is weighed before and after each transfer. From the differences in mass and liquid density, the volume delivered by the pipette is calculated. Okay, what are they trying to say in essence is that, okay, guys, unfortunately I won't be making use of this flask. Sorry, I was supposed to tell us at first. I think the first day I carried out the practical in class, some of the students actually damaged this flask. So I've been trying to get a new 25 mil, but I've not been able to do that. So I'm just going to be explaining this procedure here. I won't be delivering something to this, but I had already measured the weight of this, so I'm just going to put it on the weight and then check if it's going to give us the same thing. But I already measured the weight of this when it was still complete and intact. Okay, so first, before we start talking about the deliverance of mass delivered by these pipettes, the mass of the LMAR flask, small LMAR flask, when it is empty, the mass of that flask when it is empty gave us 21.52, right? Empty of this. So remember they said we should transfer this guy 5 successive times. You do the first one, you do the second guy, you do the third, you do the fourth, you do the fifth, right? But at the end of the day, it is the average that we are going to take, right? So if this delivered 5 mil the first time, this delivered 5 mil the second time, this delivered 5 mil the third time, this delivered 5 mil the fourth time, this delivered 5 mil the fifth time, we're simply going to say 5 plus 5 plus 5 plus 5 plus 5 in 5 places divided by 5, because the number of times I made use of this is 5, which is obviously going to give us 5. But what if, since it is the average that I'm going to record, right, you may not really have enough time in the lab, so you can just take one of this, because if you take one of this, is 5, right? If you take 5 of this and divide by 5, it's going to give you something approximately equals to 5. So instead of it to go through the stress of doing this 5 times and then taking the average, right, you can just do 1. Maybe if you want to, you can do 2, depending. If they can give you 10 mil pipette, if they give you 10 mil pipette in the lab, you can do 2 and divide it by 2. That will give you 10 mil. So what I'm trying to say is that you don't really have to complete this in 5 times. The 5 times is just to avoid any form of error. All right. If it is 10 mil that they gave to you guys, they might say do it 2 times. So it's simply going to take 10 mil the first time plus 10 mil the second time. 10 plus 10 is 20, but you have to divide it by 2 because you made use of it twice. That is in a case where they give you guys 10 mil pipette in the lab. But since 5 mil pipette is what I have here, and we are told to carry this guy out 5 times, All right, so the sole aim of carrying it out 5 times is just to avoid error. So if you do it once and it gives you 5, you do it 5 in 5 places divided by 5, it's still going to give you 5. So why would you want to stress yourself and then running it 5 times? Okay, so like I said, you're going to take water. Class, I've already done this before now, so I just feel I should just explain it again. This flask, when it is empty, is 21.52. So this flask, when it is empty, is 21.52. So when I transfer 5 ml of this into this flask, I'm not going to transfer this because it's leaking. If you transfer this into this flask, one of this, and weigh, right? If you transfer this and weigh, we got, you just give me 1 minute. If you transfer one of this, right, and put inside this flask and weight, you're going to get 26.52. That is the mass of this flask plus the mass of this 5 ml of water inside of this. All right. Now, I used to advise students that you don't necessarily have to carry out this in 5 times. Honestly, you don't have to carry out this in 5 times. Once you transfer the mass of this pipette, you put one of this pipette inside this flask. This flask alone is 21.52. The empty of this is 21.52. You now take 5 ml of this pipette and drop it inside here. All right. Basically, what you're going to have will be 5 ml of this enters there. You weigh it again. We now got 26.52. So 26.52 is the mass of this flask plus the mass of water delivered by the pipette. So if I want to know the mass of the water this pipette delivered, I'll say 26.52, which is the mass of this flask when it is filled with 5 ml of this, minus the mass of this when it is empty, which is 21.52. That will give us 5 grams. So it simply means that the mass delivered by one of this, the mass of water delivered by one of this, is 5 grams. All right. Now, if I had done this 5 times, I would have still gotten 5, because if I do it 5 times, I need to still divide by 5, and it's going to give me 5. So why go through the stress of doing it 5 times and later dividing by 5? You can just do it once, and then what am I going to record in my table? The mass delivered by this, right, plus the mass of the Lemire flask. Just put it there, except you're told otherwise in the laboratory. Please, you're going to do, when you're done with water, you're going to empty this guy. You want to do for that of the second liquid, that's ethanol. You empty this guy. You already know the weight of this guy, that it is 21.52. All right. Now the next thing you're going to do here is to use this pipette to take ethanol. Unfortunately, my glass got broken, so I cannot wait so that I don't litter my house. I don't litter this table. So you're going to take this pipette and take 5 ml of ethanol and put it here. I've done this before. So when I took 5 ml of ethanol and drop it here, what I got was 25.72. That was what I got. Like, I took 5 ml of this, took ethanol, pour it inside this flask and weigh it. I got 25.72. And guess what? That 25.72 is the mass of this flask plus mass of 5 ml of ethanol. I would have done that 5 times. I would have transferred ethanol 5 times and then later subtract the total mass minus when this guy is empty to have the mass of the total 5 times and divide by 5 to get the average, which is still waste of time. So instead of me to do it 5 times, I'll just take one pipette of this of ethanol, put it inside here, weigh it, whatever the answer gives me, and record it in the my data table. Mass of this Lemire flask, we had weighed it to be empty. When it was empty, gave us 21.52 grams. Now, when we took 5 ml of the pipette, when we measured 5 ml of water with the pipette and added it to the LMAR flask and weighed it, it gave us 26.52. I gave a brief explanation regarding to this in the video I would actually match with this one here. So this average, there is an average here. Okay, so let me just add that. Please, this average is supposed to be here. This average is supposed to be here. All right, sorry for that mixture, that mix up. Now this mass of LMAR flask, when it was empty, gave us 21.52. Right, the mass of LMAR flask plus the aliquot after mixing gave us 26.52. All right, now this average simply means that they asked us to do 5 successive aliquots of the A. So 5 successive times, average means the number of times, right? The amount obtained by the number of times divided by the number of times. So if the first pipette gave us 5 ml, obviously the remaining one most likely give us something close to 5 ml. So let's say 5 into 5 places is 25. When you now divide 25 by 5, it's going to give you 5. So you add that 5 to this this mass of this when it was empty, you're going to get this. So it's more like taking just one pipette, 5 ml of pipettes, and point it inside the LMAR flask and weighing it again. Once you do it, you're going to get 26.52. Right, for that of alcohol, which is aliquot B, if you take 5 ml of ethanol and actually empty it into this flask, and weigh it, right, the mass when it was empty was 21.52. So after you must have transferred 5 ml alcohol into this flask and we weigh it again to give us 25.72. right? So this 4.2 now is a mass delivered by one of the pipette for ethanol. Now I did more video about that. Please, for this number 6, just repeat exactly what you have here. Just what you have in to this guy, repeat it here. Now this third guy, please repeat it here. Some person may want to ask why, because if you notice they said mass of volumetric flask. This flask we made use of in this case was volumetric flask. Right, this 10 ml flask is the volumetric flask plus distilled water. This aliquot A is water actually. Right, so if you actually want to carry out this experiment, no problem, but you're going to get something similar or if not equals to this. So in order to save time, instead of you to come back and start doing this, you can just simply take the mass of the water, mass of flask plus water, and record it in the same position. And the second guy, mass of flask plus ethanol, record it in the second position, which is equivalent to this guy. Okay, now for these mixtures, how do we get these mixtures? I explained that in the video. All right, so it's for you to. Okay guys, for the next procedure, that's determination of density of the liquid. Now first, that particular one here, the procedure 7, it's basically going to be calculation. Well, if you look at procedure 6, they said prepare liquid mixtures. The volumes were suggested. We have the first one, 15 plus 5 ml. The 15 is A is water, D is alcohol. Alright, so if you could recall, this right hand side, the one that has the list label is my alcohol, and the one that has this is my water. Alright, so basically what it simply means is that I'll take 15 of A and put inside here. That means definitely you're going to use measuring cylinder to actually measure your 15 ml. Okay, or perhaps you could use your pipettes. Pipettes, if you're making use of 5 ml pipettes, to get 15, that means you have to pipette 3 times. So that 5 times 15 will actually, 5 times 3 will give us 15. Right, but for me, I prefer using measuring cylinder because it will be much faster. So I've poured out 15 ml of water. This is water inside a flask. Alright, now I carry my B is alcohol. I take 5 ml, I actually pour in here. I will actually shake. I'll shake it. Right? Because from the instruction they said use calibrated transfer pipettes and prepare series of mixtures of the two liquid varying composition. After thorough mixing and temperature measurement, use each mixture to fill the calibrated volumetric flask. Now, what I have here is actually 15 ml of A, which is water, 5 ml of alcohol, which is B. I mix it thoroughly. Okay. I come here, right? Basically, 1 minute. So I'll come here. I'll use my pipette and take out 10 ml from here. After mixing it thoroughly, I'll take out 10 ml from here, right? And fill my volumetric flask. Why are we using these volumetric flasks? Recall that we know the volume of these flasks to be 10, and we know the mass of these flasks to be 16.5. So if I should take mixture of this guy and put inside these flasks up to the calibrated points, I'm certain that the content inside the flask will be 10 ml. Okay, so that I can now use my volume to be 10 ml. So here, what I have here is actually the mixture here. I mixed it first, 15 ml of A plus 5 ml of B. I shake it thoroughly and then take 10 ml from here and fill my flask. And then I'll wait. Now, what I'm going to get as the mass of this, that's the mass of this flask plus this content is 26.09. Okay, I'll record it 26.09. Okay, of course, I'm going to display the table where the second mixture, the second suggestion is 10 ml of A and then 5 ml of B. So I'll come here, my A is water. I'll pour out 10 ml of A inside the flask here. I'll come here, take 5 ml of B, which is ethanol. I'll mix it thoroughly in this LMAR flask. Alright, so that it will mix thoroughly. Once again, I will actually transfer 10 ml from this mixture into my flask. Okay, so I'll make use of my pipette. So I'll come here, I'll take 10 ml here. Please, you can use your volume, your measuring cylinder in case. Alright, I come back here. I transfer it here. Okay, so I place this, but I must make sure I cover it. This for the second mixture. I place it here. The mass of this mixture is 26.01. Okay, so I'll empty this guy. And also empty this other one, but I don't have to empty it again. I will empty this one. I'll do the same thing for the third mixture. 10 ml of A. Okay, let's just say I come back. Let's empty this into this point so that this place will be free. For the third mixture, I put 10 ml of water. 10 ml of water. 10 ml of alcohol. I shake it very well, and then once again I transfer 10 ml from here into this flask, into my volumetric flask, and I'll wait, and I'll get the mass of the third mixture. I'll do it for the fourth mixture, and I'll do it for the fifth mixture. All right, so after which we can now carry on with our calculation. Back to the calculation part. Remember I told us earlier that I will first of all complete the table before we start the calculation, and here we go. I've already done the calculation. Now this will be done in your data sheet. The first calculation is for you to solve for the volume of flask. Right, now the volume of flask. Now if you look at this, from procedure 2, we had to calibrate the flask. Alright, so we had to fill the flask with water first, and then we had to weigh the flask when it was empty and fill it with water. When it was empty, the flask was 16.5. Alright, you could actually check it out here. When it was empty, it was 16.5. When the 10 ml flask was filled with water, it was 26.5. Okay, so when it was filled with water, it's 26.5, empty 16.5. And density of water, remember from the first procedure, I told us that they will give us the density in the lab. Okay, so this is the density 0.9973 for water. So for us to solve for the volume of the flask, we say mass filled with water, which is 26.5, minus mass when it is empty, 16.5, divided by the density of water, which is 0.9973. And when you solve for this, you're going to have 10.02. Approximately, the volume of the flask is 10 ml flask. Okay, so where are we going to record that value? Where are we going to record the value? I really recorded it here. So you look for your manual where you have this table, 10.0 ml. Remember, they said we should repeat it twice. From here, this is repeated twice. So I didn't do it twice because it's obviously going to give me the same answer. So I just had to do it once. So this is my 10 ml, this is my 10 ml. Okay, the second calculation is from procedure 3, is density of the other liquid, calculation of density of the other liquid. We did not calculate for density of water, we were told or we were given. So density of the other liquid, this rho, this symbol is rho, the same, this rho symbol is density, so this is rho. So the formula for the density of other liquid, the other liquid in this case is ethanol. Now you have to watch out, because you might get to the lab, they might decide to give you something different from ethanol. Okay, but let's say I forget, please make sure you put down your dates. There is a space for dating your manual, make sure you don't miss out on the dates. So the density of the other liquid is mass filled. This mass filled this time around is not the one that was filled with water, it's the one that was filled with ethanol. And if you look back here, mass of flask plus other liquid was 24.9, so that is exactly what we have there. It is 24.9 mass filled with ethanol. Mass of this flask when it was empty was already 16.5. The volume of the flask from our calculation here is 10 ml. So we say mass filled 24.9 minus 16.5 divided by 10, so we have 0.84 grams per ml. Okay, so where are we going to record that? This is it here. I might choose to put it on both sides, but this is it. Okay, now we want to look at volume delivered by the pipette. I want to look at volume delivered by the pipette. So we have now if you look at this, now remember we had to use the pipettes. I told us that it wouldn't make sense if you do it 5 times and divide by 5 the average, it's still the same thing, so we had to do it once. So using distilled water, because we have to use water and also use ethanol. So when we used water, the mass of the Lemea flask, which we measured, was 21.52, which is this mass of the Lemea flask when it was empty, 21.52. Now mass of the Lemea flask was the aliquots. We got here, I already explained how we got this, 26.52. So for me to now get the mass of the aliquot, that is the water inside the pipette, I'll say 26.52, which is mass of this, minus 21.52, which is this. So that's going to give us 5.0 grams. Okay, so the mass of aliquot, the mass of water delivered by the pipette is 5.0 grams. Now remember density of water, we had earlier, they told us earlier, this guy is 0.9973, so we already have the value of this. So the density, the volume is going to be gotten from, please, this place is meant to be density of water. Alright, it's going to be density of water, pardon me, there's a mistake. It's meant to be density of water. So from density equals to mass over volume. Volume will now be mass over density, which is 5.0 divided by 0.9973. So we got 5.0 ml. So the volume of water delivered by the pipette is 5.0 ml. So you come here, till down here. Alright. Now this second one will be for that of alcohol. Now we'll come back here, move down to that of alcohol. Right, we do the same thing using alcohol. The Lemea flask when it was empty was 21.52, but when you now fill the Lemea flask with alcohol, which is this guy, we now got 25.72. That of water gave us 26.52, so that of alcohol gave us 25.72. So that's how we got this 25.72. So the mass of the aliquot, that's the mass of the ethanol inside the that was delivered by the pipette, will now be 25.72 minus 21.52. That gives us 4.2 grams. Now it's now say density of ethanol. Density of ethanol, this particular one, remember we had earlier calculated this guy from procedure 3, which is procedure 3, got this to be 0.84. So that's the density we're going to use. So density equals to mass over volume. So volume of ethanol will now be mass all over density. We have this. Now this is the expected volume. Please just take this expected volume to be the volume of the pipette. If they give us pipette volume to be 10, is it to be 10? Is it to be 10? But since the one we made use of was 5 mil, so here is going to be 5 mil, here is going to be 5 mil. So here, that's why I record the expected volume is 5, actual volume is 5. Alright, for the density of the mixture, I'm just going to, explain one of them, so you should be able to do the rest by yourself. Okay, so this is it. Now remember the first mixture, which is 15 plus 5 we had earlier, right? Okay, please want to solve for the density of the mixtures. All right, for the first mixture we have 15 plus 5, right? 15 mil plus 5 mil. That's, remember they gave us suggestions for the mixtures 15 plus 5, 10 plus 5. I'll just do for the two of them, so you can use the sample and complete for the three of them. Now for the mixtures, the first mixture is 15 plus 5. All right, so this is A, this is B. All right, A is water, B is alcohol. So the mass of the flask, it was empty. I said this one is constant because we already gotten this mixture, right? We got this to be after I told us how to get this 26.09. we got it after we must have mixed the 15 plus 5 and then transferred into a volumetric flask and weighed, and then we got 26.09. Okay, so the mass of the mixture 15 plus 5 is 26.09. The mass of the flask when it is empty is 16.5. So for us to now get the mass of the mixture, we now say 26.09 minus 16.5. This is equals to 9.59. Right? Now remember that the density of the mixture is what we want to solve. We had earlier transferred the mixture from a linear flask to volumetric flask. So the volume we're going to use here is going to be the volume of the flask, which is equal to 10 mil. Right? So density equals to mass over volume. Our mass is 9.59 divided by 10. So the density for the first mixture is 0.59 gram per mil. Okay, so we're going to record that. You come here for the first one, 0.959 gram per mil. 95, please. This guy is not part of it. 0.95 gram per mil. It's part of it. Sorry about that. I didn't see the first one. So, okay, so we actually proceed to the second mixture. Right, the second mixture, from our calculation, the mass of the second mixture with the flask is 26.01. So we'll say for the second mixture, we'll say for the second mixture, right, the mass of the mixture is 10. Mixture is 10 mil plus 5, right? So this is going to be 26.01, the mass of the mixture plus the flask minus the mass of the flask when it was empty. This is the mass of the flask when it was empty. So this becomes 26.01 minus 21.52. Right, so if you press your calculator, we're going to have 26.01 minus 21.52. So this becomes sorry, please, the mass of the flask is not 21.52. please, sorry, the mass of the flask we're using is not a linear flask. Okay, It is volumetric flask. It's not linear flask. Sorry for that mix-up. Right, the mass of the mixture will now be 26.01 minus 16.5. This is where you remember we had transferred into the volumetric flask. So this becomes 26.01 minus 16.5. So we'll have 9.51 grams. So the density is mass over volume. 9.51 divided by 10 mil because of the flask is going to give us 0.951 gram per mil. Okay, so that's how we got the density for the second guy. So you should follow the steps to get the other density. Please, if you have any question, please drop it on the comment section. Please do not forget to subscribe. Right, the video took us so much time to edit and to prepare, so the least you could at least do for us is to hit the subscribe button and share. Thank you very much. I will drop the one for the next practical.